This video we are going to discuss precise definition of limit of a function at a certain point. So a is a selected point, so you know that function may not be defined at that point. We are not interested in that point when it comes to limit, right? So we are more interested in the functional values, the behavior of functional values as x approaches a from left and right side. So we can see that from this slide here. So as x approaches a from your right hand side, what happened to the functional value? Functional value slowly approaches L. At the same time, x approaches this point A from your left hand side, and the functional value slowly approaches L. That means as x tends to A from both sides, so your functional value approaches L. So actually this is not a definition, this is not that rigorous. We are going to provide a rigorous definition for the limit. So let's start define the rigorous definition of the limit, right? So I can say, so here, so this function approaches L anyway as x approaches A from left and right side, right? I can say that. So if you close very close to L, the value of L, I can say that I can guarantee you that I'm able to find a interval, an interval around A anyway. So if you are close enough to this limit L, if you are close to L, so I can guarantee you that I can find a range around this A. Let's see how to do that. I consider any ribbon around this L, right? So the width of this ribbon, the entire ribbon strip or vertical strip, is 2 epsilon. So this ribbon, so let me draw this one. This length is epsilon, and this length also epsilon, and the length of entire, so this length of this vertical strip is 2 epsilon, right? So this is a ribbon around value of L, right? If I choose any ribbon around value of L, so here epsilon is any positive number. If you you can make the size of this strip smaller, right? If you draw any strip around this L, so you are able to, I can guarantee you that I'm able to find a range of I'm able to find an interval around A such that these elements, these x's, so these x values in this interval, so maps into this strip here, this strip, red color strip, horizontal strip. So this is this one is the definition. If you consider any strip around this value of L, so and the length of this strip is 2 epsilon, right? And what is the value of this one then? So this is L, L plus epsilon, and the upper bound of the ribbon, right? And this is the lower bound. This one is L minus epsilon. Why? So this is this value is L and this length is epsilon. If you take out epsilon from L, you get this point here. L minus epsilon, and this is L plus epsilon. For a given ribbon around L, I can guarantee you that I'm able to find an interval around A such that these points map into that ribbon. So, and the length of this this interval is centered at C A, and the radius of this interval is delta. So that means width of this width of each size is delta, and delta, and this point is A plus delta, and this one is A minus delta, so the limit of the function at A, so limit of the function at A is equal to L, right? So that means you are able to, so if you give any vertical strip around L, so epsilon can be any positive number. You can reduce the size of this strip as you like, right? Okay, so whatever the length of this strip is, I guarantee you that you are able to find an interval around A such that these elements in this on this interval maps into this strip. So if you write this in mathematically you can write that statement, so that idea, right? So if you if you have any given so a ribbon around this L, so that means any epsilon greater than, so the any epsilon greater than, if you make this ribbon small enough, I guarantee you that you are able to find an interval around A. Yes, that means I guarantee you that you can find an interval delta, and the size of this interval is 2 delta, right? So and any point in this interval maps into this strip. Okay, let's write that down. So any point in that means x in between A plus delta. So this is the upper bound of this interval, and the other one is A minus delta. So if you select any point in this interval that maps into this strip, that means your functional value between L plus epsilon and L minus epsilon. So that implies the functional value f of x, so between L plus epsilon and this is L minus epsilon. So this is the so precise definition for limit, right? So what does this mean? So you are able to, if the value if the limit of the function at A is L, that means you are able to find, so if you are given any strip around around L, so the size of this strip can be anything, right? It could be very small positive number, right, or bigger, right? So any number, any positive number here, that's why any epsilon, any positive epsilon. So I guarantee you that you are able to find, so we are able to find an interval around A, so that means we can find at least a one interval, right? So this delta depends on epsilon, right? So this delta depends on epsilon, right? So which is so and all points in this interval maps into this, this area here. So this one maps into here, this one maps into there. So everything, yep. So if you select, if you pick any point in this interval, the functional value between L plus epsilon and L minus epsilon.